Good afternoon, everyone. My name is Taylor Woods. This is my colleague, Sebastian Blais. Thank you for giving us this opportunity to speak with you today. We are here to tell you about the lean manufacturing project we did through SherwinWilliams through our lean manufacturing course. We were brought in to help with the lean optimization of the plant. Lean optimization is about eliminating waste in all aspects of production, be it materials, time, space, or energy. This reduces costs and cycle times, all while simultaneously improving quality and above all, creating a healthier and safer workplace. This is not only useful in a factory setting, but anywhere where efficiency and performance and costs are important to success. In a hospital, lean could help the speed and cost of care and save lives. In a kitchen, lean takes mise en place to a new level. When married to a French chef, mise en place is something you get quickly tired of hearing. In English, we say, a place for everything and everything in its place. In lean manufacturing, we call this 5S. Lean manufacturing solutions can range from a complicated redesign of an entire factory or be as simple as labeling and organizing tools. For a home example, this could mean redesigning the entire bathroom or be as simple as learning to put the toilet seat down. Maybe not as simple as that. So to begin with our work at SherwinWilliams, a little history is in order. In 1866, Henry Sherwin and Edward Williams started SherwinWilliams in Cleveland. Since then, they have grown to be a Fortune 500 company with over 4,000 paint stores worldwide. In March 2016, Sherwin-Williams acquired Valspar for approximately $9 billion. This gives a starting idea of just how large this company is. This is drastically different from the Rexdale plant when it was acquired in 2009. The Rexdale plant was a small family-owned business. However, this small family operation had difficulty competing with bigger corporations and eventually went out of business. The facility was then sold and exchanged hands many times before being acquired by Sherwin-Williams in 2009. As you can imagine, this facility, having started as a small operation and having changed hands several times, was not up to the standard of a large corporation. Since the acquisition, this plant has been operational. However, constant upgrades and procedures are constantly in place to help bring the facility up to Sherwin-Williams corporate standard. In order to bring this facility up to standard, auditors are brought in to inspect the facility, record violations, and note areas where standards are not being met. These findings are then ranked based on their importance and the timeframes which they must be completed. Of course, any safety issue is of the utmost importance. As it so happens, one of these safety issues were noted, specifically the lack of a proper fire plan. Prior to our arrival at the facility, all the necessary fire equipment did exist. However, there was no plan in place for how it should be used or what should be done in the event of a fire or other emergency. The most pressing concern was a lack of accurate and up-to-date facility map, complete with all the emergency equipment and exits, as well as the safest and quickest escape routes. This is not only below company standard, it is a violation under the Fire Protection and Prevention Act, which can result in heavy fines as well as a plant-wide shutdown. As this is not only a health and safety concern, but a financial one, it was of the utmost importance and given the highest priority. We were asked if we could help with the creation of these maps and fire exit plan. This was an interesting task for us since it was not one we would have expected to complete it and was well outside of our project scope. Nonetheless, we were uniquely qualified for the task. As mechanical engineering students, we have become proficient with CAD software and through our lean courses have a very good understanding of plant layout and design.
And so we went to work. It turns out that rudimentary layouts of the map did exist. And although the people at Sherwin-Williams did provide us with some information on the overall dimensions of the plant, they were fairly crude. Most parts of the map were legible and out of date, so therefore they were fairly inaccurate and it was hard to pull any information from them. They did, however, give us a great place to start. The biggest part of this task was to reproduce these maps. So we first uploaded the original drawings given to us onto AutoCAD and pulled all the information necessary and all the important information that we viewed would be good for our next step in creating the maps. We then took several tours of the plant to update the map layout and made the necessary changes to our AutoCAD file until we had an up-to-date and accurate map that we can work with. Afterwards, we printed these maps and continued to tour the plant, and we pulled all the information such as locations of the fire extinguishers, pull stations, eye wash stations, and shower stations, as well as the emergency exits. We followed the exact same procedure for the property layout, and we included the outside fire exits and the assembly area as well. With the overall map complete, the next task was to decide where best to place these maps so they can be seen and easily accessible to all the employees in the plant. After speaking with several employees from each department, we selected 8 different locations where we can place these maps. And in addition, we also discussed the best possible means of egress from these locations. We then created individual maps for each area of the plant and marked their location on the map as well as the safest evacuation route. Having had the opportunity to discuss these maps with many of the workers in the plant, we are confident that these will provide necessary and accurate information should an emergency arise. Creating these maps was a unique challenge because we never had to undertake anything like this before. And it was also very rewarding because we had the opportunity to utilize our multiple skills that we learned at Mohawk College in a real work setting. We also became very familiar with the staff there, and they were able to share their insights. Those insights were instrumental to our ability to solve the problems. With their help, we were able to come up with the most beneficial solutions and the overall product to aid their work environment and make a safer work environment for them. Over the course of the initial project, we walked through the plant many times, and the result was we were able to observe production at different times throughout the day and also at different times throughout the week. This was also a tremendous experience because we were able to witness the problems and how they were solved and handled by the staff there. And we were almost like the flies on the wall, and we were able to observe the day-to-day difficulties the individual operators had to face and how they worked in their team environment. It also made it possible to identify problems not yet recognized.
Switch and pointer.
So I'm going to show you the original drawings that they first given to us. So this is what was given, and as you can see, it's very hard to pull any information. The internal structures, some of the walls in the building were torn down and no longer there. So we basically tore around the plan and we relabeled all the different areas. And we also updated the internal walls and the structures within the plant. There were also not really any dimensions given, so we really had a really raw piece of drawing to work with. And this is this is the map of the property layout that we digitized onto AutoCAD. As you can see, whoops. As you can see, there's over here the outside fire exits, and we placed them at all the fire exits as well as the assembly area, right at the bottom right corner. And this is the map that we came up with. So as you can see, it's night and day compared to what we were given. All the areas are labeled, as well as all the different entities inside the map. So we placed the locations of all the pull stations, fire extinguishers, fire exits, eye wash stations, and as well as the walkway paths. And this map is one of the 8 maps that we created and that we were going to place around the plant. So this map, its purpose is it shows the fastest and most safe and the safest way to evacuate the building. So this little red dot, its purpose is to show where the map will be hung. So in between the filling department and storage and can storage. So all the employees who work there will see the map, and these lines that deviate from the point, it shows the most efficient way to exit the building should an emergency arise.
Another problem that popped up was the lack of an HVAC layout for the plant. This is part of the necessary documentation required by the SherwinWilliams Corporation to meet their standards, and is necessary in order to make improvements over the current system. Overall in the facility, there is only typical ductwork in the front office to provide heating and air conditioning. Throughout the plant, however, there are several exhaust ports to remove contaminants from the mixing tanks to the outside containment unit. There are air vents removing contaminants from the air on the production floor, and single space heaters are also spread out around the floor to provide heat to certain areas in the winter months. As these have not been updated in many years, you can imagine these are not as effective or as efficient as one might hope when spending a large amount of their life in this setting. Wintertime is a big issue, as only the spread out areas directly under these heaters receive any recognizable improvement from the conditions outside. Summer months are just as problematic as high temperatures have a drastic effect on air quality. These ventilation systems are not as efficient as removing particulate or chemicals from the air as they could be. This was another high-level concern due to the health and safety of those working in these conditions. And without a clear understanding of the current state, it is difficult to make adjustments. As before, we asked one of the plant supervisors to show us around all the areas of interest so we could mark them down. Locations of the tank ventilation systems were a challenge because they were not accessible or easily seen. But with the help of some plant operators, we were able to separate and identify and map the locations. The outside ventilation and heating systems were pretty straightforward. The HVAC system in the main office was not necessarily difficult, however, it did require lots of time on a ladder and minor allergy symptoms as we removed ceiling tiles around the office to locate the ductwork. Once we've compiled all the information necessary, we just added it to the map, and we had produced our, this can be used to update for a new air quality management system. Although this has been an easier project, owing due to the fact that we had already created these layout maps for the fire maps, we felt it was important as it will not only help the staff be more comfortable and productive, but it will address the air quality in the plant. It's fairly obvious when you're either hot or cold at work, but contaminants in the air are not always easy to detect and can have a profound effect on health. After completing these maps, we were able to start on the optimization of the plant. This was a bit challenging because a new layout for the plant had been proposed. This new layout design was based on amalgamating the labeling and filling stations into single cells. I'll have to skip a bit here. Having walked around the floor many times, one of the most apparent problems was congestion moving throughout the plant. In order to address this, spaghetti map was created. Spaghetti map sounds more like something my daughter makes on the kitchen floor than an effective problem-solving tool. However, it is very useful when trying to understand choke points in the facility. We first shadowed several employees in different departments and recorded the order of operations that must be completed for each set of tasks. We then number these on our blank layout map for each operation and simply connect the dots, thus creating a line of travel for each task laid on top of the other. Wherever one of these lines crosses, it represents a possible choke point. Once the current state map is created and understood, the work of untangling the Christmas lights begins. All throughout the plant, we found inventory, unused machinery, and finished materials placed in the direct path of traffic. When we applied what we had learned from the proposed new layout, we found that many of these problems we had discovered still did exist in the new layout, and in some cases were even worse. Fortunately, many of the solutions we found to solve these problems also worked to solve the problem in the new layout as well.
So we'll show you the spaghetti map that we created.
I'll just run through this.
And as you can see, this is initially what we got with the spaghetti map, and you can see the high levels of congestion within, how's the laser thing? There we go. High levels of congestion within this area over here. And this is our new proposed layout for this, that we use this spaghetti map for. And as you can see, the spaghetti map diagram displayed a very high volume of traffic between the loading and unloading docks in the plant. And so therefore, one of the first changes that we proposed was to flip the receiving and shipping areas. Because as of now, the receiving areas, it's in the same spot as the finished goods, and the shipping area it's in the same location as the inventory. So it doesn't really make sense, because the forklift has to travel from one part to the area to the next, and it would just be a lot simpler if they just flipped it so that the loading area is next to the inventory, so there's not really any travel needed there, and the finished goods is next to the shipping area. So once again, it would eliminate a lot of congestion and unnecessary forklift travel within the plant.
This is the amalgamation of both maps put together, just to be a little bit more easy to understand when we were presenting it. This here is their new proposed layout. As you can see, especially with the receiving and shipping docks on the opposite side, There's now even less room for travel in here, not to mention operators working in this direct area. So this, if the shipping or if the receiving end was on the same side as inventory, no fork truck would ever have to come past this point to drop off the pallet. And similarly, no fork truck would ever have to come past this point in order to drop off finished goods.
So in the end, we learned a lot throughout our time at SherwinWilliams. We learned how lean manufacturing can be used to solve real-world problems in a real-world setting. We acquired knowledge from those who worked at the plant, and we gained a lot of valuable insight in how a plant runs and from top to down how it operates. And this is our fire map posted at the main entrance. As you can see, they posted that at the main entrance, and they also used the other smaller maps at the 8 different locations around the plant. And this is them, they're halfway done their proposed layout. And hopefully that all of our work that we did pays dividends in the end, and they can improve the efficiency within their plant.
This was a very interesting work experience because we saw not only how quickly priorities can change and how the job you brought in to do is not necessarily the problem you were there to solve. It showed us the importance of quick thinking and adaptability, as well as the importance of good teamwork and leadership. We'd like to take this opportunity to thank Sherwin-Williams for providing this wonderful opportunity. We hope that this was valuable for Sherwin-Williams as it was to us and helps to strengthen the relationship between them and Mohawk College so that other students may share in these amazing opportunities. We'd also like to thank our teacher, Dr. Louis DeRazio, who not only taught us the necessary skills to succeed in these projects, but who consistently takes the time out of his busy schedule to organize these placements and similar opportunities for many of his students over the years. He has always been willing to go the extra mile to help us attain the real-world experience and know-how to help us succeed in all aspects of our education and careers. We'd also like to thank George Miltenberg, who as a teacher was able to bring a wealth of personal experience, and as our new Associate Dean has been ever present and supportive through these projects and understood their importance and what they mean to his students. We feel very fortunate to have the support of industry professionals, teachers, and administrators who not only believe in these courses, but put themselves in the line to bet on our success. We look forward to bringing these experiences to our professional careers so that one day we may be able to help students such as ourselves. Thank you for your time.